Alright. Tonight we're going to work on a shelf queen. This is an amp that's been lingering and waiting for me to complete. And we're going to dig into it tonight. I'm in between projects right now, so we're going to try and finish this up and get it working. I don't really know exactly where I left off, but we'll figure it out. So let's get into it. So it's in pieces already. I've already done some work on it, and we'll go over what I've noticed so far. It appears that the pots have been removed. I don't exactly know why. I don't know where they are either, which is mildly concerning. But this board has been recapped. I'm just going to briefly go over it and make sure that all the caps are replaced. This might be a boring video, so be warned. There's going to be a lot of investigative work to kind of see what I did and where I left off. I don't know why I removed the pots. That's not usually something I do. I have spares, I believe, but I'm not sure why they were taken off of the unit. So I'm gonna have to dig into that a little bit. I also don't remember the exact values on these, so I have a few different sizes. So we're gonna have to dig through this and do a little bit of homework to try and figure out what the heck I did here. So I guess that'll be a little bit fun. So the pots are kind of available. I think I found these on Mauser. They are direct replacements for the ones that were in there. I don't know if they're the same as the originals, but they will work. I'm just concerned about values right now and whether or not they will be the right value. Okay, so this might have been the reason why I did that, if memory starts to serve me right. I believe the knobs pulled out. I have two pots in here with the knobs pulled out. So it's starting to come back to me a little bit. Yes. This is why it's good to be a hoarder sometimes. So the original pots were this knurled style, and for whatever reason, when I pulled the caps off, it took these with them, and they're like swaged on the back, so you can't really put them back in. You could file it down and pop them in on the work, but then the knobs just fall out, and that's no good. So I think I just decided, instead of messing around and trying to put these back together, I'll just replace them. So these are similar to the ones that are used on the Super Junior. They are compatible. I should have a knurled one in here somewhere in my dual. Let's see. Yep, there it is. So here's the original knurled. So that is why they were removed and why they're going to be replaced. I believe they'll just be a drop-in. Maybe I have to make a couple modifications. Let's see. Well, the plates are pre-drilled, so I don't have to worry about the little tabs on there. The original ones did not have tabs. These ones do. There's like a little tit that hangs off the edge of the alignment. Let's get the camera fixed a little bit. It's a little bit out of range here. If I can find my remote. There it is. Alright. So, alright, I know why we did that. So for knobs, what we're going to do, and unfortunately it won't be original, but it'll still be Sunfire, so The Super Juniors and the newer ones use these like little tapered knobs with this little white indicator on them. The original HRS knobs were just like a kind of cylindrical knob with just a couple of little lines on the side. So we'll have to do a knob swap on there, but I don't really think that's the end of the world. If somebody really cares about the knobs being original, well then buy a different amp. That's my solution to that problem. Alright, so that's probably part of the reason I probably had to order those knobs. I'm seeing a few caps on here that still are not replaced. Like I said, I'm going to go through every cap just to make sure that it's done. Now I have a lot of UVZ series on here. I used to use those on Sunfire stuff. I switched to UPS pretty much on everything now just because they're rated for a little bit longer service life. Still all Nichicon caps, so there's no junk on here. It's quality parts. So we got one cap here that's got to be replaced. I wish there were a different color. It'd make it a lot easier. So it looks like we missed one on this board, and then we got to do the pots. Let's get into it. Here we go with the porno links again. How do I block the links from going into the chat without disabling chat? That's the question of the night. The $1,000,000 question. So I'll save these original ones even though they're damaged. Never know. Might run into a pinch where I need to, you know, use a pot for something. And these guys, the replacements that I'm going to put in there are 10K. The original ones were 10K, A103 audio taper. Or A taper. I don't know if A is audio. I think there's A and B. One of them's audio, one of them's linear. Doesn't really matter that much. It just changes the way that they you know, work throughout their range. They both can hit the same values. It's just the slope of those values is a little bit different, so you might have to be a little more finicky on the adjustment. This one is 502, and that's what, 5K? Easy way to measure a pot, just for the sake of killing time while I heat up my solder sucker, is you just go between the two end legs and you leave the wiper out of it. Make sure you're on resistance mode. So yeah, we got 4.4K across the range on that one, so it's a 5K. And our replacement that's going in there is about the same, 4.6. Pots are kind of funny. You never really get the full range out of them unless you buy precision ones. So, it's coming back to me. Let's put these back so we don't get all messed up and screwed up here. We'll save our knobs too. I have a little collection of knobs. Never know when I'll get one that has a cracked knob or something and needs a replacement. So, that is where we left off on that. Good to know, right? This is going to be a learning experience for everyone. Solder sucker's heated up. I'm just going to go ahead and throw these pots back in. One leg at a time. Make sure you get the pot fully seated and down onto the board. Nothing is worse than not having a pot line up after you put the board back in, and then you got to take it all apart just to get the darn thing lined up. Extremely frustrating. Now, I'm going to use the solder sucker. These actually have some decent sized planes on them. So I want to be able to channel a little bit more heat in there and make sure these have good joints and they're not cold joints. Might be a little overkill, but if you've watched any of my videos, you'll know I'm not a fan of doing anything half-ass. There's more links. Goodbye. Jeez, I need a moderator in here. Alright, same with these. The traces are kind of thick and fat, so we just tack it in place with the small one, and then once I get it lined up to where I want it, we'll lock it in with the let's see, this board goes, yeah, so it's on the back, so it's hard to get it lined up. Gotta play the visual game with this one, get it close enough so if the pins do bend a little bit, they're just barely flexing. I forget where this Sunfire came from. Now, these boards are prone to lifting and damaging pads if you get them too hot. So you do have to be careful. They're basically like two single layer boards, one on each side. I don't even know if the through holes are plated, to be honest. I've never really researched and looked, but I do know if you get them too hot, they don't function very well. The traces actually lift off. So don't leave the iron on there too long. It's better to go in there with a lot of heat quickly than a little bit of heat and bake them. As long as you get them close, there's a little bit of wiggle room on there, so it's not too bad. Alright, so back to looking at our caps here. There's one cap, this guy here is a S.Y, whatever that is. That's gotta go. Everything else looks good. I just don't want to send this thing back out with, one cap that's gonna fail. That would be a tragedy. Alright. 0.047 microfarad at 50 volts. It's an oddball. It's a Sunfire cap, but I do have them. Actually, wait, maybe I don't. Is that 0.47 or 0.0? Oh, 0.47. Alright. That we do have. So I don't think they make an electrolytic that small. 0.47 at 50 volts. And when you get to these small values, the UPS doesn't make them in that series, so you gotta go to like the UKL series or one of the other ones. Just make sure you're using a good brand. Panasonic, Rubicon, Nichicon. If you're using a good brand, you're not going to have any issues. If you're buying your capacitors on eBay and Amazon, well, I can't say I didn't warn you. I don't know what they do about supply overseas, but I assume, every country has a reputable distributor list. So you should be able to find somebody that can, get you some good parts at a reasonable price. This guy, The connections in this thing were really weird too. So it's gonna take me a little bit to get that figured out. We'll get there. Like I said, this has been sitting on the shelf for a while. I wanted to finish it so I can get it up online and sell it. I'll post this on the Carver site too. I like to go to the respective forums and, you know, offer up anything to somebody that might need it there first before I just throw it up on eBay. I haven't logged in there in a long time too. I probably have a zillion messages. Apologies to the moderators if they're mad at me. Alright, so this looks like our input board bag. I try to put everything in bags too. It really helps keeping everything organized. Get rid of that garbage cap. I already got thermal paste on me. Never fails. No matter what I do, I get covered in thermal paste. I'm a little bit out of it tonight. I'm getting a late start, so I'm actually not going to put this board in yet. I'll tell you why. I want to put the amplifier board in first. I'll never get to the heat sinks if I don't do that. So let's check this guy. We got everything redone in him. No, 2 caps are not done in this guy also. These 2. These little boards here are a nightmare to do and not damage them. But they have been recapped. Looks good, a little dusty, but good. One of the things I think I might do is change the heatsink pads to silicone on these. Right now they're mica. Sunfire does use silicone pads on a lot of their stuff, which I applaud them for because it eliminates all the thermal grease. I might keep this one consistent and put silicone pads in there. Alright, let's get these 2 caps out. And they don't bend their cap leads. That's another thing I really like. You know, they bend everything else, but the cap leads are not bent. It's almost like somebody thought, like, hey, maybe down the road somebody's going to work on this thing and recap it, so we should make it easy on them. Let's see, 220 at 16 volts. This is probably an oddball size, and that's why it did not get replaced. But we have them now. So, in order to get the right size for this, we're going to use UVZ series, 220 at 16. And this actually is a single-sided board, or these boards are single-sided. At least this one is. Meaning the through holes aren't plated. There's just a traces on each side and pads. But the solder connections are all done on the bottom side. Old school technology. Easier to work on though, much easier to work on. So we'll get it tacked in, we'll straighten it out, make sure it's seated on the board. And then go on to the last one. These are actually pretty powerful amps too. I think they're somewhere close to the 1000 watt range. I like the HRS series. I've had an HRS-10. Nice sub. And these are sealed box too, so they make very, very tight base. There's no passive radiator in them. It's an audiophile sub. Audiophile grade sub. Capacitors are clearly marked on the board. Like, I would have to say this is probably the golden era of Sunfire. The Bob Carver days. Before everything got China'd. I was going to come on yesterday, and I know I always say that, oh, I'll be on tomorrow, and I'm never on tomorrow. I had a work project that I was really under the gun for, so I had to get the project done so I could meet my deadline. And by the time I was done, I was just exhausted from being on and near computers, so I decided to just call it a night and chill for a little bit and get some sleep. We're going to take these, put these in with our dirty pads. These mica ones, and they're still good. You can reuse them. They just have to be cleaned off. We are going to go no goop on these. That is the plan. The easiest way I've found to get thermal paste off is to use a razor blade. Don't push hard. You'll scratch the plate a little bit, but that ain't gonna hurt nothing. We'll make sure it's nice and smooth, but a lot of this stuff is like crispy because it's old. So if you just kind of lightly chisel it off, makes the cleanup a lot easier. That way you're just not smearing a bunch of goop all over the plate. Comes off in one nice chunk. And thermal paste does have a service life. I don't know exactly what that life is, but it does need to be periodically replaced in order to be effective. If you're a computer nerd, you'll know that. Especially if you're like extreme into like overclocking and stuff like that. So we have a reasonably clean plate, a little dusty. Let's get some pads. Let's see. We need 4 for the FETs and 2 for the outputs. I gotta find the box that they're in. So here's our 2 outputs. And our 4 FETs. I recently just bought a bunch of these too, so I have no idea where they are. Of course they're not in there, so we'll use big ones. You can just cut them down. It's fine. Until I dig out my thermal pads that I bought. I might have taken them into work. Who knows? Could be. Let me check one more spot. Seeing as I can and I have the time. That's fuses. Hardware. Oh, we'll just go with I don't know where they are right now. And we'll use the regular pads. So if you have 2, you just lay them sideways and you can cover 2 of them. It does leave a potential for one of the parts to short, but I mean, it's got to push all the way through that to short out. Chances of that happening are extremely slim. If you really want to, there, we'll just cut the pads. How's that? We'll snip them. That way nobody's got to worry. Just kind of guess that it's the right size. Cut them down. Hopefully a little straighter than I just did. We need 4 of those. They have to be the width of the device. If they're off, you might have to redo it. For the big ones, it shouldn't matter. They have insulators around the screw holes. Alright. I am actually going to redo this one. This one looks like garbage. Looks like I was drunk when I did it. Bear with me. I'll have to order some more smaller ones. These things are cheap. You can get them anywhere. Amazon. eBay. You can get them from the distributors. They're cheaper on Amazon though. Stuff like thermal pads and that, you can skimp on that type of stuff. Silicone thermal pads, a silicone thermal pad doesn't need to be anything fancy. I don't know why these are so hard to cut straight. Here we go. Reassembly time. Just verifying really quick again that all the caps are done. And this thing might not work when I plug it in. I don't know. You know, I just assume it's just a aging cap issue. That's what I always start with. Start with old caps and then kind of refine it from there and hone in on what the problem actually is. Which means that yes, it may have to come apart again. It's just part of doing diagnostic work, but you got to start off with a known template. You can't just kind of guess at everything all the way through. Transistor clamps on these are also really nice. Sunfire uses these like nice little spring-loaded arms. High quality. If memory serves me correct, two of these long ones go into this plate here, and 2 of them go through the transistors. And there should be, 1 plastic screw. Alright, we're good. And the ones that have thermal paste on them were the ones that went through the transistors. And I don't know why, but I have 3 of those. We'll put the dirty one on the other side. This thing's all slippery from getting silicone on it. When I was having my technical difficulties making my other video. They do this a little bit weird. Because of the grounding on here. I don't understand why they chose to do it this way. Let's get the plate screwed in first and then we can adjust. Oh, there is a 3rd one, so I'm missing a screw. No, I'm not. Alright, I screwed that up. The long one, the extra long one, goes on the side with the output board and filter. And the reason is so the ground wire can attach to that. So here, let me put one of the short ones in. Because the input board only has 2 mounting points, right? Yes, 1, 2, and a other screw. I remember now, a little bit. Long screw goes here on the top. I wasn't lying when I said it's been a while. It's been very many whiles. Let me get the bottom one started. If I can get it lined up. Yeah, don't snug them until you have both of them in, because otherwise you're going to flex the board. You don't want to flex the board. Alright. That is much, much better. Now the fun part. Getting the thermal pads where they need to go so we can clamp them down. You can cheat. You can put a drop of thermal goop on them. That helps. Not always necessary, but sometimes it helps. What I usually do is I just lift the devices up, get the pad in there, and then smush it down and kind of hope that it holds in place. Just by pressure. But getting them lined up is quite challenging. Making sure that, you want the whole device covered. So you gotta eyeball it a little bit. Would have been much easier not cutting them, but I wanted to just demonstrate that there's more than one way to do this. And there isn't really no right or wrong way. However, if you're the one working on the amp, you do it how you want to do it. This one's got to come out. I got a whole bunch of dust and hairs and crap on it. That's not good. Dog hair is not good for cooling transistors. Probably should have dusted this thing off before I started on it. Gotta mute really quick. Alright, let's go back to, I just blew out the thermal pad on that one, and the other one. Tell you what I'm going to do. I'm going to clear off one of the originals and actually cut them to the right size. Or I'm going to get frustrated enough that I'll just go back to the thermal paste and put the mica ones back in. That might happen. Either way, they still all need to be realigned though, and the alignment part is kind of a pain. Trying to get the thermal paste off, because if I get it on my fingers, I'm going to be upset. Alright, let's try and be a little scientific about this. So that one's cut to size, that one's good. This one is quite wide. I'll take a healthy 1/16 of an inch off of this one. Maybe it'll help me keep my cut straighter too. And the reason I'm trimming them down is I want them covered under the devices. I don't want the edges of the devices overlapping, because that's no different than having the hole in there. If you want to ensure full, 100% chance of insulation, electrical insulation, you want to make sure that it overlaps the devices on the sides a little bit. Again, if you have the right heatsink pads, then you don't really have to worry about this. But I am out of silicone T0220s, so this is how we're making do. Just use some larger ones and hack them. We're doing hacks tonight. And once they're in place, they're pretty forgiving. And I'll make sure that the devices are crunched down real good so they don't move when we screw them in, because that is another concern. It's a little tedious, a little annoying, a little boring, and I apologize, but it needs to get done. And you need something with a sharp point when you're doing this, because you got to be able to manipulate the pads, poke them and drag them around a little bit. Sometimes they will fight you going underneath the devices. You only need them under the non-insulated tabs too. The ones that are plastic on the outside don't need thermal pads. These two that are way back in there are just fighting me. Come on, get in there. You want to try and not have them overlapping at all. Because if they're overlapping, you're going to run into some issues. I don't have enough light. And I really can't show this on camera. There's no way to zoom in to actually get this. It's just, you just have to understand what I'm doing. I'm just lining up these thermal pads. And the frustrating thing is when I move one, the other one moves. Like they fight each other. Alright. That looks pretty good. So before doing anything else, I'm going to take something and I'm just going to push the transistors down into the pads. And what I'm hoping happens, which usually doesn't happen, is it just pinches a little bit against the plate. And it'll hold it there long enough that I can get, at least one of the screws started. That will keep them in place and keep them from shifting. A little drop of silicone does help. Thermal adhesive. There is one more transistor that's got to get pushed down. There we go. Alright, everything looks pretty good. And we'll check for shorts too. I'll show you how to do that. This is going to be tricky too, darn it. So, the legs of the transformers are in the way. So you got to get under that, and I think by getting under that I already screwed up my pads. So now I got to recheck them, and then go back to retightening. Alright, we're still good. Barely, but we're good. Can be frustrating a little bit. You know, it's there's not a whole lot of room to work in here. And you got to kind of work blindly until you get all the parts back in. But once you get one screw in it, it gets a heck of a lot easier. And if you have fat fingers, like, I feel really bad for you because you are going to hate this. Alright, there's one screw. Get the third screw in. Starting this nut is going to be near impossible. The nice thing is they have integrated washers on them, so when they do start, they're not too bad because you don't even need a pair of pliers on them. Oh, I got lucky there. I got super lucky. Alright, let's see if we can tighten these down. I'm pushing the pad to try and, or pushing the clamp to try and hold the devices down so those pads don't fall. Again, this is much easier if you're not using silicone pads. I'm just purely doing this for the next guy. And of course the nut won't tighten because it has goop in it. Nobody said it was going to be easy tonight. Let's see if I can get in there with the needle nose. Needle nose are definitely not the right pliers to use to hold nuts, but we just got to get it started. And they had some kind of goop on these screws, which is why it's fighting me. These ones you can be a little aggressive with and crank them down. It's perfectly okay. Get them cranked down and get them locked in place. Again, I know you can't really see this, but you get the point. Yeah, put a little torque on there, get those things locked down. Alright, so clamps are in. And it's going to be near impossible to see, but I'm looking through the little crack back down in here, making sure that the pads are where they're supposed to be. And we'll check for shorts. I can tell already we're not going to have any, but we'll just check it anyways. So to check and see if you're fully isolated, just go to the plate with one probe. And then we're going to check the center leg of each of these devices. Now we do show a short there on this guy. I don't know if that's in circuit or if it's a screw up on my part. That could be something in circuit. Or it could have just been a capacitor charging, because now it's gone. Nope, my meter powered down. Battery's low, of course. So we are showing a short to there, so what is that? It shouldn't be grounded. It should be isolated from these posts. It could be because the MOSFET's, one of the large FETs is touching, maybe? This guy in the end? No. Why are we shorted? No, I gotta pull it back off. We have a short on one of the transistors, which is extremely maddening. Just for sanity check, let's check the large devices and see if it's going through there. And it is. So maybe we don't have a short, maybe it's just one of the bigger devices touching the plate. So what I will do is get the thermal pads underneath that guy. Which is equally as challenging. I don't know why why didn't you just turn this board around 180 degrees and put the connector on the other side of this? Wouldn't that have made more sense than having to fight with these? You know, they probably assemble them before they put the transformers on, but still, it doesn't make it any less annoying. I like Sunfires, but this seems like an issue that could have been avoided. Finding the through hole in the pad is challenging too. There's not a whole lot of room to work. Yeah, it's all whacked out now. Alright. We're in. Now the even more challenging part. Washer, lock washer, nut. And you just can't see it. I guess I could remove this output plate and that would make it a little easier. I've done these before, this is not new to me. I just don't remember it being this challenging. Magnetic tweezers to the rescue. Alright. Washer. So the device is like spring loaded now, because I bent it. So when I try and push it down, it goes down and then it pops up and just launches the washer off. It's gonna be maddening to tighten, I can tell you that already, because I'm not gonna be able to get the nut started on there. Alright, screw it, I'm taking this off. I'm getting frustrated. Patience are thin tonight. I was hoping I could just squeeze my way in there and make this work, but Not happening. Alright, now we can get in there and kind of see what's going on. Except we have no screw. Where's our screw? It fell out. Alright. Try again. Start over from scratch here. There is... the washer. Lock washer. And a nut. Again, you can be a little aggressive with tightening. You want to, I mean, you don't want to crack the device, but you do want to make sure that it is secured to the plate. So get it tight, squeeze it a little bit. Let's check for shorts again. That should fix the short, I think. I think it was just the device touching the plate. Yeah. That's what it was. No short, just heatsink touching the plate. Which is good. Alright, I got one more of these to fight with. Then one more thermal pad under this little transistor here on the end. And we can continue with our reassembly. Definitely easier to do with that board removed. Appears we are missing a lock washer. I don't know if that had one or not. The smaller device. I'm going to assume it did. They're supposed to be getting a blizzard. I wonder how much snow is coming down right now. The great blizzard of 2021. If you live in one of the warmer states, they're saying by Friday night we could have 20 inches of snow. It's really not a blizzard, but it's a hell of a lot of snow. I lost the lock washer. I need a shorter screwdriver too. A nut driver would probably be the appropriate tool to use. But I'm not going upstairs right now to get a nut driver. Mess with this. I just want to get this on. Get this nut to start. I need a short screwdriver. Little baby screwdriver just to get it started. And holding a nut with a pair of tweezers is an absolute nightmare. Alright, we got it started. It's like doing surgery. Amp surgery. On a tiny little screw. All that messing around for a MOSFET screw. Alright, one more. I'm just flipping it around because I don't know if I had a extra lock washer or not. I do not remember. This device doesn't need to be actually it doesn't need a thermal pad either. It should be, I'll double check the bottom, but it should be a plastic package. Yeah, this is plastic, so we're just going right to the board with them. And I don't think he got a lock washer. If it did, I apologize because I don't have it. Unless it's still stuck in the bag. I'll double check the bag. Come on, get on there, you bastard. Let's just give it a look because the bags are still at the top of the garbage can. No. And no. What'll happen is I'll finish this and then I'll see a washer sitting on the desk somewhere. Now I'm paranoid and I'm looking through everything to make sure I didn't lose it. I don't think he had one. If he did, he's not going to get one. It'll be fine. I'll put a drop of E6000 on there, it won't go nowhere. Hardest part is getting in there to hold the nuts. Nut driver definitely would help. It's so damn tight, I can't get in there. That ain't gonna work, those things suck. Alright. We're tightening down. So the little bit of thermal paste that was on the back of those devices should be fine. You don't need a ton of thermal paste. It's not beneficial to have too much thermal paste. A little bit goes a long way. And I'm gonna abuse this amp. I mean, I'm gonna get it up to temperature. Put 300 watts through it continuously into my silent speaker, and we're gonna get it hot. Make sure it can handle the full load for an extended period of time. And I know this thing's rated for 1200 watts or 950 watt, whatever it's rated for. I don't remember. I'd have to look it up. but that's not continuous power. If that was continuous power, it would have a much larger fuse in it. I think there's only a 5 amp fuse on the input. Maybe even a 4. I don't know. We'll see that in a minute. Alright, that's tightened back down. Let's put our pliers and stuff away. Now we can do some connections here. That goes to the input board, that goes to the input. This we can connect in here. Now we can do this other board. And this guy's the easy one. Somewhat. So this grounding wire, that's kind of important. I don't know why you need a grounding wire. You have, you know, these posts right here that should be connected in, but they're on an insulated, this insulated pad, so I don't know what that's all about. Seems a little janky to me, but I'm not going to question it. We will have to do a little E6000 blob or silicone blob on our LED to make sure that we don't have an air leak. That is important. Let's get our input board screwed in. I still have to recap the power supply too. I guarantee you there's some bad caps in there. Sunfire was notorious for bad caps on the power supplies. Let's see where this thing was made. Is this made in Washington? CSA Canada approved. Nope. China. It's made in China. Damn it. Still a good amp though. I thought this was a USA made one. It is not. So probably somewhere, if you go overseas in China, they probably have a Sunfire HRS-10. I could almost promise this design has been knocked off. Alright, get our pots secured back in. This thing's gonna work. We're gonna make this work tonight. That is my goal. Get this fired up, making music, and it won't be making music, but we'll look at it on the oscilloscope. If it starts making music, I might get murdered. Wife will come down here with a club and the dog and attack me. Alright, pot nuts, you want to make sure they're fairly tight. Again, this is not the right thing to be tightening them with. My pliers have disappeared. By disappeared, I mean I'm using them on some other project in the other room. They don't need to be like I'm a power lifter tight, but snug enough to where they're not going to vibrate loose. Got to do that by hand. Alright, we're going to set the crossover to bypass, phase to 0, volume to minimum. Always do that. And I guess while we're at it, we can put the knobs on too, the new knobs. The fancy white knobs that fit these pots. Tell me that doesn't look factory. I mean, I guess if you're a collector or an aficionado, you'd notice, but for the average user, they just want some working pots, so good enough. Alright, we have our input connection, that's in. We have our amplifier output connection, this gets a zip tie here. And then we have this grounding wire. So what I do with the grounding wire is I put the grounding wire on first, and it kind of sits over that little lip on the edge of it. Then I go with the star washer, and then I go with the keep washer. I think from the factory they do washer first. I don't. This is how I do it. Whether or not my way is right, I don't know. You really need a nut driver for this. I don't want to go outside. I'm going to do the right thing and go get a nut driver. I don't want to, but... Hey, what's going on, Michael? If you stick around, since I took a nap today, I might work on your spare amp next. I'm hoping that this will be up and running, and I know you wanted to see what was going on with that, so give me a minute. I gotta go out to the garage and get a nut driver. This amp's almost done. Alright, I went out and it's actually 5.5 millimeter, which is rather annoying, but that's pretty close to 7/32. So I can use one of my little old school Craftsman wrenches, if I can get it in here, to get interesting. It only fits in the one side, and it won't fit on there, so I'm gonna have to do this manually anyways. Oh, we got it. Yeah, one of those weird 5.5 millimeter. It's used a lot in electronics. It's a very weird size. I don't even know if the socket would fit down in there though. This is a pretty tight area. I love these little wrenches though. These things are pretty awesome. So all that's left on this amp is the input capacitors, and then we're ready to put some juice into it and power it up. You don't want to make this too tight, you'll actually snap the screw off, but snug. Snug is good. Get a sip of coffee here. Hopefully when the snow starts pouring down it won't kill my stream. I had a lot of problems last night with my stream cutting out. Seems like it's doing alright. I can see my transfer rates are going pretty good, so hopefully it stays like that. No promises though. No promises, no guarantees. We gotta replace our big capacitors, which I should have. These are rated at 160 volts. I don't think I have 160, so we're just gonna bump it up to 200. Should be the exact same size. Actually, I have some tall ones. We could put some tall ones in there. That wouldn't hurt. Should clear. Let's see. I thought I had some of these monsters, but maybe not. So many darn capacitors now. I can't keep track of all of them. I got too many. Too many weird amps I've been working on. Well, I have something that'll go in there. We'll make it work. First thing we got to do is switch out our soldering tip. And then find the big one. I am forever losing my large soldering tip. I don't know what it is. I had that thing the other night. There it is. Getting old and senile. Can't remember anything. Alright, we'll let that heat up. Get the light out of the way so it's not blinding everybody. Come on, camera. Focus. There we go. So let's see. While that's heating up, we got two large input caps, and underneath this connector that's going to be really hard to get to. We got some other caps down there. These are all power supply filter caps. These things are incredibly hard to get off. They're good connectors, but the best way I've found to do it is to use 2 screwdrivers. Get a little crack in there, get it started, and then just use one on each end and just pry it up. Otherwise you're yanking on the wires, you're yanking on the board. It's a recipe for disaster. If you pull one of these wires out, I don't have these pins, so I don't even know if you could still get them. A lot of these connectors are to the point now where they don't make them anymore. So let's see, we have 6 caps in here, and two big boys. So I'll pull the big ones and then we'll work on the little ones and put the big ones in last, and then we should be able to fire this up. Check the fuse while we're at it, while we wait. Fuse looks good. I don't know if it's the right value. It's supposed to be 4 amp. That's a 4 amp. So fuse looks like it got hot, but it's good. It hasn't failed yet. Alright, let's pop out these big caps. These big ones are usually good. You can sometimes get away with leaving them in, but the problem is the little ones behind it are almost always bad. And we'll test a couple of those too. Takes a lot of heat to get all this solder melted. Even this, you know, this is a pretty high-powered iron, and this struggles. I might have to bust out the big boy. I might just take this bracket out, to be honest. Make it a little easier to work on. Just because this one in the corner is really hard to get to, so I need to take the bracket off. Maybe we'll just take the bracket off. Start there and see where that leaves us. That might be enough to get everything in there and get working on it. Plates are a little hard to handle because they are quite heavy. I think I am going to use the large solder sucker, just because there is a ton of solder in here, and it's going to be hard to get that all out. I just don't think I have the power with the even with the smaller one. Like, it heats it up, but it doesn't, it hardens before I can get the whole thing to pull. And like I said earlier, it's better to hit it quick and fast than it is to hit it slow. And yeah, I'm gonna damage the board. It's already snapping and crackling. Alright, let's turn this way in case it decides to fall over, and I'm gonna get the big boy. If I can find him. Used it a couple weeks ago, it should be on the shelf. I'm not too concerned with resoldering, but desoldering the big one will make a difference. This thing is an absolute monster when it comes to unsoldering caps. I forget how many watts. I think it's either 100 or 150 watts. It needs to be cleaned. It's dirty. But this should clear out the massive solder blobs pretty easily. Give it a minute to get good and hot. If you sit there with the solder sucker on a smaller iron, you're just baking the traces, and I don't know, it's just not good for the board. There's moisture in these old boards, and they start to like hiss and pop and crackle, and make sure I'm getting the pins there. I hope these aren't bent over. It looks like it kind of is. They are. They bent them over. I don't know why these are supposed to be snap-ins, but... So even the big boy's going to have problems getting this one out. That's like extremely frustrating. Why would you bend the leads over on the two largest caps in there? So I'm going to just clear the holes like I have. And try not to burn the place down with this. And I'm going to cut them out. The new ones will not have their leads bent. Should be pretty close to coming out now. It doesn't help that the board is loose. Alright, should be good to go. There's number one. Got one more. Gotta clean out my sucker here. It's getting clogged up a little bit. Shouldn't have said nothing. Would have been alright. I don't really use this thing very often though, so I used to use it all the time. It actually used to be the only one that I had. But like anything, if you want your tools to last, you gotta service them and clean them. So give me a minute to clean this thing out because it has zero suction power. And it's just absolutely littered with solder. And then we'll get back to finishing off this recap. Definitely one of the best tools I have though, the old Hacko Super Solder. I think it's got 808 is the model number of it. It's been knocked off by China now, so if you want one, you can get them pretty cheap on Amazon. I think they still call it an 808, but there's a bunch of different brands that make them. But this is the original Super Solder sucker. Here we go. 2 more joints. I do need to be kind of quick with this because the wife is going to go spastic because these things are pretty loud. Way better on the suction power though, so definitely need a little maintenance there. that should be good. I should be able to snip the leads and yank this thing out. I've worked on some of these before. I don't ever remember them having bent leads on the filter caps. That's new to me. You can see there's some pad delamination under there. That's probably why they put the solder on so much. They weren't getting good connection on there. Or I don't know. It's kind of weird. They didn't clean the solder mask off, but their solder just like layered on top. We'll solder them in real good when we put them back in there. Man, this does not want to come out. It's loose, but the cap is glued to the board. Six to 10 inches. Where are you located at? I don't remember. I'd have to look up your address. We're gonna get killed with snow tonight. 20 inches by Saturday. Come on. This is the most stubborn cap I think I've ever had to try to pull out. There we go. Tulsa, yeah, Oklahoma gets snow. I didn't think Oklahoma got snow. I've been there before. I guess they get snow in Texas in certain parts though, so I guess I could see Oklahoma getting snow. Just not that you don't, not something you'd associate it with. Do they shut the city down when it snows like that? I was in Tennessee for work one time, and this is interesting. I'm shaking this cap on here, and the whole pad's wiggling. Yeah, I was in Tennessee, and they shut down Chattanooga because they got snow. It was kind of funny, and I mean, we're used to driving in that. Like, we'll do 60 on the highway when there's a lot of snow. It's normal for us. And I was in a rental car, and we were just cruising along, and people thought we were like crazy. I couldn't believe that we were driving. I mean, I guess if you know how to drive in the snow and you're used to it, it's not a big deal, but it was funny watching everybody like freak out because we were driving on the roads when there was some snow. There were accidents everywhere. I mean, people sliding off the road, and couldn't believe it. Like, it was maybe just like a dusting, maybe an inch of snow at the most, and just everything just went nuts. It's just another winter for us here in Ohio. We get, some winters are real bad, some winters are real mild. It just depends. So I pulled the cap out, and one of the pads was like starting to come up, so I'm going to reinforce it by over soldering it. There's really no other way to fix that, and I actually will bend the lead on this one because I want to reinforce that joint. It's just one of the things you kind of have to do sometimes. But any future repair on this, like, the tech will instantly know what happened. So as much as I'm against that, sometimes you have to do it. Well, be safe out there if you got to drive anywhere. Drive slow. I'll be heading into work tomorrow, and there'll probably be at least 4 inches on the highway. And I'm sure, we have our share of crazy drivers. I'm sure you'll see people spun out and probably a few accidents here and there, but for the most part, they try to keep it on the road. Let's see, time check 2:20. We still got some time. What time is it in Tulsa? Yeah, new caps that I'm putting in here will also be snapping, but I'm not going to bend the leads over like they were done on that. That's just ridiculous. Like, they're not going anywhere. Especially, I usually put a drop of silicone on them. I am doing like a little bit of a reinforcement on this one trace that's lifting up off the board a little bit. Just taking the lead of the new cap and just wrapping it around there, and then I'll solder over the whole thing. I'll show you that. I'll zoom in. After I make sure it's done right. So I have one leg soldered in. And then you can see this pad in the corner here is loose. So what I'll do is since it's only a single-sided board, I scraped off the solder mask, and I'm using the leg of the capacitor to this other lead here, and I'll just over solder the whole thing, so it'll give you a really strong joint. It's a little bit of a hack, but it works really well. The only other thing you can do is just do a full like trace replacement, but that's kind of overkill for something like this. I mean, once you solder the original one back on, it should hold anyways, but this is just a precautionary just to make sure that it's a higher quality repair. So that's what it looks like when you're all done. Pretty much factory. Alright, we got a couple more to do. That delayed us a little bit, having to fix that, but these older amps you gotta do that on. Let's get this other one out. These are usually the caps that go bad on the big ones on the power supply. I just wanted to test one of them just to verify. That one's good. Of course, since I decided to test them, they're all going to be good. Nope, this one's toast. Completely bad. Won't even read anything. Oh, nobody can see that. Sorry, forgot to zoom out. So these are the power supply filter caps for the lower voltage supply. Cap number 1. Close to tolerance, within tolerance, if it's 20%. Cap number 2. Absolutely zero. Completely no good. replacements. Real good. So just a little verification as to why you really need to get in here and replace every cap on these older units. It's a very, very, very good chance that they are bad. Make sure our polarities are correct, and we'll get this guy soldered back in. Alright, a few more to go. The little ones I'm going to just automatically assume are bad as well, so I'm not going to check those. We're just going to say they're bad and they need to come out. I forgot how much of a pain these are to actually work on. Just a weird angle. The amp sits at a really weird angle. 47 at 16 volts. Running low on these bad boys. Only got about 4 left. I assume both of these are the same value. At 16. Let's get these two in. 4 more caps before power up. If you did nothing else on these larger Sunfire amps, this is the board you want to focus on. This board and maybe these 2 large caps that are on the amp board. If you want to do a quick and dirty repair, that's where I would go. Can always refine it from there. So I'm just tacking these in place right now. I'm going to do all 4 of them, get them tacked, and then I'll do the final solder after I flip the board over. I just don't want to keep flipping it. It's a little bit faster to just swap them all and then do it all at once. That's 2 little guys. 470 at 16. These little ones are all for the low voltage supplies, and these low voltage supplies is what controls the audio circuits, so these are probably more important than any of the other ones. $470 at 16. Again, we're using UPS series caps whenever possible. It's mainly what I use. Check and make sure our polarities are all good. We will basically have a brand new amp. The only other thing you really have to worry about on an amp this vintage is resistor values starting to drift, but that generally doesn't happen. Let's see if I can get a little more light back there. Let's move the plate. That's a weird angle. Alright, let's finalize these joints. Alright, the two big ones, and we can power this guy up and see if we've achieved success. I won't go into long-term testing on this one on the video. I'll just do that off camera. That way I can get onto the next amp. Since you're patiently waiting, I don't feel like I need to make you wait for testing of an amplifier. It's kind of boring anyways. Alright, so I don't have 160, so we'll put 200s in there, which is equally as good. It's a much higher quality cap. Going from REC to Cornell. Same value, just higher voltage rated. Just make sure you put the polarities in right. That is the most important thing, and they are marked. So I am using snap ins, but I'm not going to bend the leads on them. I'm snapping them in. I'll make sure that I silicone everything real good. And that should be all that is required. I'm going to actually use my thicker solder for this. Put these caps away before I knock them over. Put the pots away. Those don't need to be out. And solder this bad boy in. Alright, I made a liar out of me already. This one does have to be bent. And I will tell you why. So, since part of the pad here is just non-existent, and this side of it's kind of lifting a little bit, I am going to bend this one lead over. I hate to do it, but I have to do it. Again, these boards are generally pretty robust, but for whatever reason, this board is fighting me. I've not experienced them in this level of deterioration. I'm sorry, future tech, whoever works on this, I apologize. I know it's like not a preferred thing to do, but I also don't want to risk having a crappy connection on one of the more important parts of the circuit. So I have to break my rules. That's probably why they put so much solder on top of these, because they realized that they were having some connection problems and just figured, well, we can just cover it up. That's my guess. They just covered it up. So we'll do the same thing. We'll just cover it up. At the same time, we'll try not to do any more damage to the board. The bigger traces are a little more forgiving than the little ones. It doesn't help that the boards are also single-sided and not plated through. If they were plated through, it would be much easier to work on. Alright. Definitely not my favorite thing to do. I'll try and get this little back corner filled in. I don't think I will, but we can try. It's almost like TIG welding. You just gotta add a little bit and let it cool off. Okay, recap is complete. Get rid of our junk old caps. Clean up a little bit, and I am eager to power this bad boy on. I see a couple leads I have to trim though. I don't want those causing problems. All these big caps will be siliconed in, so we don't need to worry about them vibrating. The little ones really you don't have that many problems with. The big ones you almost always have problems with. I do not. Oh, speakers are here. Let's see, I don't remember where the speakers go, but the leads are literally right on the back of it. Since I'm not going to be cranking this up, I'm going to go to a regular speaker. I have my custom adapter cable that I made here. It goes from terminals to terminals. So if I get sound, I will put it through the mini scope. So, well, where is my mini scope? Here it is here. Let's see if we can just do it all at once. Save a little time. Oh, no mini scope tonight. I apologize, my battery's dead. And I do not have the charger set up for that right now. You just have to trust me when I say it's working. How's that? Alright, volume's all the way down, phase is at 0. We're on bypass. Now I need a power cord. Where is my power cord? I'm allowed to be a little disorganized when it's late at night. Well, I had a nice length power cord. I'm going to assume that I used it when I was moving the computer, so we will just grab whatever I can find. I do like that Sunfire on this model put a standard connector on there instead of just a cord with like the legs coming out of it. That's always nice. Alright, we'll start off current limited. Yeah, I'll explain silent speaker. I'm going to regular speaker right now. But I'll talk about that in a minute. Let's fire this up first. Alright, we got power. Standby light came on, that's good. Let's give it some audio now and see if the standby light will go bright. Input, left, right. I heard something. Power on my function generator. So I'm at 40 hertz right now. It's on and it sounds beautiful. Frequency control is working. Phase is working. And volume is definitely working. Let's take it down a little bit. These things really like, these amps, they like sub-hertz levels, so right now I'm at 36 hertz. If I go lower, the volume is going to dramatically increase. Let's see if I can... I don't think the microphone will pick up that low frequency, but it's woofing away. Sounds really good, nice and clear. No hum. What I will do is I will turn off my signal input. So there is line hum when there's no... Okay, there we go. Yeah, there's no audible hum even at higher levels. I did have hum when I left the inputs connected, but that's because there's a grounded connection there and it's going right into the transformer. You can actually hear the bass through the microphone? That's kind of cool. I usually stick my finger on there to make some of the sound. Alright, well, I'm going to call this one complete. I'll redo the zip ties, silicone everything in place, and then get this into somebody's home that needs it. I'm going to test it later. I will explain the silent speaker though. I'm not going to hook it. I'll hook it up to your amp when I get it going. I need to find my power supply for my little oscilloscope. But for now, let's set this aside and move on. One more amp out of the basement. The wife will be happy about that. Alright, so tell you what I'm going to do here. I'm going to end this stream, and then I'm going to start another stream with the KLIPSCH amplifier. So, as always, thanks for tuning in. I'm going to be right back. I'm just going to restart the stream. I'm going to change it to stream number 35. That's going to be a KLIPSCH synergy. So, give me a few minutes. Let me get set up. I'm going to end this, and I will be right back. Remember to like and subscribe if you've not done so, and we'll see you in a couple minutes.